students, welcome to follow up. Let's have a look at problem 2654. Minimum number of operations to make all array elements equal to 1. And in this video, we're going to explain how to reduce the problem and how to solve this problem. First, we're going to have a look at the problem statement. So here we are given a zero-indexed array called nums, consisting of positive integers. So we can do the following operation on an array any number of times. So we select an index. This index is inbound, and then we replace either nums I or nums I plus 1 with their GCD value, right? So we want to return the minimum number of operations to make all elements of nums equal to 1. If it's impossible, we're going to return -1. So here the GCD is in the sense of mathematics or basic number theory. So here we have two examples. In the first example, it requires 4 operations. So here is an explanation. So in example 2, so the output is -1. So basically, if you look at this, the elements here, so their GCD of all the numbers here actually is 2, right? So therefore we cannot make this. So in other words, we need to have 1 as a GCD for certain number of for a subarray or for the whole array. So that's the first intuition, right? So let's also look at the constraints. First, the length of this list is bounded below by 2 and bounded above by 50, and both ends are inclusive. So this basically gives us the bound of the problem size, right? So 50 is not very large. If you consider a square iteration, let's say double for loop, so 50 times 50 is 2500, right? That's still doable. So here the elements is bounded below by 1 and bounded above by 10 to the power 6. So this one, so it basically tells us it's positive, right? So now we are ready to look at the problem. So first, let's look at several simple examples to digest the problem. So here we can assume nums equals, let's see, 1, 2, 3, say 100, right? So in this case, due to the way of the operation, right? So we can choose this index and then make this one 1, right? So we have 2 ones, and then we choose the. So let me mark this. So choose index 0 and make index 1 element to be 1. So we get this one, right? And this the ones, right? And then if we choose the first index, and then we can make the second index at 2, right? This will be 1. So we get this one, and then so we can choose this index corresponding to 1, and then make the 100 to be 1. So we get 1, 1, 1, 1. So here we need 3 operations, right? Here we have a 1, and we have 3 remaining elements, right? So this is the one example. Now let's look at another one. So let's reverse this one. So we have this one, and we have this. So this also we need 3 operations. So you can first choose this one, right? So if we choose this one, so what do we get? So we choose this I. So here is let's see. We replace either of number I or nums I plus 1 to be their GCD, right? So for this one, I can choose this one. I can make this nums I to be 1. So we get 2, 3, 1, and 1. So now let's do it again. We can choose this. We can always do this. We can choose this index corresponding to 3, and then 3 we consider 3 and 1. We make 3 to be 1. So we get 2, 1, 1, and 1. And then actually we can choose index 0. Then we get 2 and 1. We make 2, 1. So 1, 1, 1, 1, right? So we get 3. So 2 comments here, right? first, for this example, right? So here, if we have this one, we need 3 operations. No, if we add more ones, right? No matter how many, right? It does not count, still 1. So these 3 are non-1 elements, right? So this is the comment 1. Secondly, the minimum operation is determined. However, the specific procedures are not unique. For example, for this one, we can first choose this one, and then we make the first element corresponding to 2 to be the GCD of 2 and 3, because their GCD is 1, right? So we get 1, 3, 100, and 1, right? And then we can choose this one, right? So their GCD is also 1, so we can make this one again 1. So this is the second operation, right? So we get 1, 1, 100, and 1. So next you can choose this one, index 1, or you can choose this one, and then both can reduce 100 to be 1, right? So we get 1 and 1 and 1 and 1. So in other words, so the minimal required operations to make all elements to be 1, if possible, is determined, is unique. However, the specific procedures are not unique, right? So this is the one. This is the 2 comments. So overall, we observe that so the element 1 or GCD 1 is special for this problem, right? And secondly, so if the GCD of all the numbers in the nums is greater than 1, and then we cannot make all elements to be 1, so we return -1, right? So this is what we observed. So next, our plan basically is like this. So we want to find the minimal GCD1 subarray. So the minimal GCD subarray is that, so a GCD, a continuous piece of the original array, such that the GCD of the elements in the subarray is 1. So actually what we want to find is the length, right, of the minimal GCD1 subarray. I would say subarrays, because the subarrays are not unique. However, the length of the minimal GCD1 subarrays is unique, right? So once we have this, actually, because the GCD of these things are so assume that we have zeros. So basically the big picture is like this. So if nums contains 1s, right? Then we just need to return n minus n ones, right? Like here, right? So if no ones, so if they have a GCD1 subarray, let's assume the length is ls, right? So we need ls minus 1 steps or operations to make the GCD subarray to have a 1, right? Now we have 1 ones, so we just need to use n minus the ones, right? In other words, we reduce the general case to the case that it contains at least 1, right? Otherwise, if no GCD1 subarray, we return -1, right? So that's the whole logic, right? So basically, we are ready to do the coding now, right? So for this, first, actually, I want to introduce a variable called the m. This is the length of this nums list. So by assumption, so the length is at least 2, right? So now let's count the ones, so n ones, right? So this nums, we use the count method, right? So count 1. So if n ones, in other words, there are already ones in the nums list, so then we can directly do as in the first 2 lines here, or the 2 examples here, right? So we just need to return n minus n ones. So each operation changes a non-1 element to be 1, right? So otherwise, we need to find the length of minimal GCD1 subarray, right? So for this, actually, we can use a double for loop due to the nums length, which is bounded above by 50, right? So for this, let me first introduce a variable. This is called float infinity, right? So we want just this float infinity just to make a comparison purpose, because we are going to use the min function. So now we are going to iterate. So we want to check if we start from index I and ending at index j, both inclusive. We want to see if this corresponding subarray has a GCD1. If so, we're going to update the length, right? So this is basically for I in range n, right? And then for j, we are going to iterate from I, including, right, up to n. Then what we want to do, we want to check. So we can use math GCD. So compute a sequence of numbers GCD. So this function actually is also easy to iterate by ourselves. Actually, if you have followed our previous video, so actually you could find relevant problems. So with that done, let's first call this function. So we're going to compute the GCD of these numbers. So start from nums I and ending at nums j, right? So basically we have j plus 1 and minus I elements, right? So if this equals 1, in other words, from index I ending at index j corresponds to a GCD1 subarray. So we need to update this one to be min, the previous stage, and then j minus I, end minus start plus 1, right? It's just simple counting, right? So after the two double loop, so we can find the length of this one. So then if this guy is still float infinity, so in other words, we don't have any GCD1 subarray. So in this case, it means that all the number as a set, as a whole, so they have a GCD greater than 1. So we cannot make all elements to be 1. So in this case, we just need to return -1. Otherwise, so if you write like, you can write it like this. So we're going to return length -1. So because we want to make 1 out of this GCD subarray. And then now we have a 1, so we just need to use n minus 1, right? This additional operations to make all the non-1 elements to be 1. So essentially the first part. So up to now we finished a format of solution to this problem. So before we make any comments, let's first do a check. Yeah, it passes the first example. Now let's look at the second example. We need to return -1. Yeah, it does. Now let's look at the generic case. Yeah, it passes all the generic cases. Actually, for this problem, in the first try, actually I forgot to check this situation. The reason is that I didn't read the problem very carefully. I assumed that all the elements are greater than 2, or equal than 2. And then actually there's no 1, so we do not need to check this case, right? Though in the process, in the second part, we need to reduce to this case. So that's about it for this problem. So here we want to make two additional comments. The first one is that if you do not have some idea for approaching a problem, so maybe you can use some explicit examples to help you digest to understand the problem logic. And then we can use problem transformation or problem reduction to reduce the general case to some patterns or some example case. Then we approach the problem. So in this video, actually, we took this kind of guiding principle or methodology, right? So that's about it for this video. And if you find the explanation here of use, you're welcome to follow me up in YouTube and also check out the corresponding playlist for different types of problem. So with that said, thank you.